This math talk looks at finding the lowest common multiple of two numbers. We often call it the LCM, lowest common multiple. And what exactly does that mean? Well, if I consider this question, find the lowest common multiple of 12 and 15, I'm looking at 12 and I'm looking at 15 and I'm saying, what is the smallest number that both 12 and 15 divide into? Well, let's see. We could consider 24. Well, 24 is divisible by 12. It goes in twice. However, 24, if we try and divide that by 15, it fits in once and it has a remainder. So we would get not a clean answer like a 1, a 2, or a 3. So that's well, we could look at possibly 30, because 30 divided by 15 is 2. However, 30 divided by 12 is not a whole number. It does not go in a whole number of times. In fact, it's 2.5. So once again, that's not our lowest common multiple. The lowest common multiple is the smallest number that is both evenly divisible by 12 and 15. Possibly a good strategy would be to look at a multiplication table involving 12s and 15s. So here's how we do that. Looking at the multiplication table for 12 and 15, we look down the multiples of 12 and we see 12, 24, 36, 48, 60, 72. When I look down the multiples of 15, in other words, 15 times 1 is 15, 15 times 2 is 30, and so on, we see 15, 30, 45, 60, 75, and 90. And once again, we see this 60 and 60 appearing in both tables. So the lowest common multiple in this case is 60. Now you're probably saying, this could get really challenging if we have more than two numbers, or if the numbers are really large. This could go on for quite some time. And I would say, yes, we need another strategy. And so I go back to our video on prime factorization of composite numbers. And we do this. I'm going to look at 12. And I'm going to look at the prime factors of 12. So I would probably break that down into a 4 times a 3. 4 is still composite, so we break that down into 2 times 2. The 3 is prime, and now we have the 3 prime factors, a 2, and a 3, all multiplied together. I will do the same with the 15. I will break it down into its prime factors. Well, this is actually pretty simple. It's 5 times 3. Both 5 and 3 are prime. If we are trying to build our lowest common multiple, it must contain the maximum of each type of factor in each number. That is to say, my lowest common multiple will be built from the factors of 12 and the factors of 15. Now, when I look at it, 12 has 2 factors of 2, so my lowest common multiple must contain 2 factors of 2. I also look at 12 and say, oh, it's got a factor of 3. So at a minimum, my lowest common multiple must also have a factor of 3. Now when I look at the 15, I say, okay, what hasn't been covered? Well, the 15 contains a 5, which was not in the 12. And so now I have all of the factors that you would see in the 12, which would be the 2, 2, and 3 part, and I also have all of the factors that you would see in the 15, which is the 3 and the 5. So in fact, this number, when multiplied all together to get a larger final value, would in fact be divisible by both the 12, which is the 2, 2, and 3, as well as the 15, which is the 3 and the 5. And so when we look at this and we work it out, 2 times 2 is 4, times 3 is 12, times 5 is 60. And lo and behold, we have this value of 60 that appears in our table. Now, this is going to be our strategy going forward simply because our questions become more complicated as we go. Let me give you an example of that. If I have to find the lowest common multiple now of 15, 24, and 42, I've got 3 numbers there. I would probably have to build quite a large multiplication table until I found 3 identical numbers in each of 15 and 24 and 42's multiple columns. We already know that 15 factors to be 5 and 3. So it's 5 times 3. 24, I will construct a factor tree and I will break it down into 6 and 4. Both of those numbers are still composite. 6 breaks down to be 2 multiplied with a 3, and the 4 multiplies to be a 2 multiplied with a 2. And then finally 42, maybe a little more difficult for some of us, but I recognize that comes from my 7 times table. It is 6 times 7. 7 is prime, but 6 is composite, so we must break that down into 2 times 3 times 7. So now when I try and build my lowest common multiple, it works this way. I'm going to start with my 15, and I'll say that I need a 5 multiplied by a 3. Now I've got the 15 covered. When I look at the 24, I already see the 3 built into my lowest common multiple here, so I don't need to add that in, but I do need to put in the 3 2's. So I need to put in a 2, and a 2. And then, finally, when I look at my third number, which is 42, I say, well, we've already got in our lowest common multiple a 2 and a 3, so there's a 2 and a 3, but I'm missing a 7, so I need to build a 7 into that lowest common multiple as well. Let me show you essentially how these numbers are built into that lowest common multiple. Taking a look, the 5 and the 3 would be our 15. The 3, the 2, the 2, and the 2, those multiplied together would be equivalent to our 24. And finally, the 3 multiplied with a 2 multiplied with a 7 would give us our 42. And so all three numbers are built into that lowest common multiple. Working this value out, it's actually quite large. 5 times 3 is 15, times 2 is 30, times 2 is 60, times 2 is 120, times 7 is 840. So our lowest common multiple is actually quite a large number, and as you can imagine, it would have taken quite a bit of writing and quite a bit of construction of a multiplication table until we found that common factor of 840. So it comes back to that great skill that we learned in the other video, which is prime factorization. That's how you find the lowest common multiple, and I'm out of time.